Yeah. Settle down. That's not what I want. That's the other one. There we go. Oh, so it's working now. Alright, so it's streaming, and is it recording? Start recording. What's up? Oh no, YouTube's recording. Okay, we're good. What's what?
We actually streamed.
Yeah. But nobody watches the stream, they just watch the recording. What are we at? Radical expressions was yesterday. We're going to go back to the radical expressions in a second because I know some of you will have had difficulty with some of the stuff and we didn't really finish it. But the solving quadratic equations will be easy. Now, do you guys see this on your screen right now? Steak, do you see this on your screen? And you shut it. For the second time, you've disobeyed me. Does anybody have it open? Okay, it's all good. Okay, let me make sure. Oh yeah, I see it here. And don't worry about it. Go plug in. What is it? Is it an iPhone? Sucker. Okay. Chloe's there. Just make sure. Hi. All right, Chloe. If you have any questions, just raise your hand on the thing and I'll hear the little ping. So, let's do 3.5. It's going to take us about 15 minutes and then we're going to go back to 3.4. By the way, the quiz, proud of you guys. And what do you have to say? No, proud of you too. No, what do you have to say to me?
Thank you.
For making it so
Easy.
But if you can do those questions, you can do any of the questions. You understand? You got to believe in yourself. Well, that's different. Who cares about domain range anyway? But you know what was curious about that whole quiz was the first question was supposed to be easier than the second question. Do you understand what I'm saying? Because it's a part of the process. It's one of the steps in the process of completing the square. Some of you couldn't do the first question, but then the second question is like, no problem, boom. And the second step of completing the square was all you had to do in the first question. You just had to pick the magic number. You understand what I'm saying? And then you're supposed to factor it, which it should be an automatic because you pick the number, so then you know what it factors to. It's a perfect square, right? You know what I'm saying? But live and learn. Make sure that your mistakes are your best teachers. Yeah. All right. So back to this. The title is Solving Quadratic Equations. I really encourage you guys to read the questions whenever you're doing an evaluation because yesterday several people didn't read the question. And the question said, add the missing number that would make the following a perfect square. Easy. A perfect square trinomial. And then write the factored form of the trinomial. So that means you have a trinomial that looks like this. Oh, this is like exactly the thing.
Yeah.
So I'm going to go with something that I know I didn't use.
17.
Let's go with 24. So I know that the magic number is going to be, I know what the number is going to be, but for those of you who aren't sure what's going on, this and this, right? So in question 1, I was asking you to do this. Just fill in that blank. Somebody asked me, can you change that to a negative number? My answer was yes, you could, but then you'd be wrong. You understand why? because that's the L part of your FOIL. It's always going to be positive, whether this is negative or not. What's up? Sky, bro. But you were doing something. Anyway, so, yeah, you wrote some stuff there, so. I didn't understand what I was asking you for about this. Here's your trinomial, and then you rewrite it with a sign, of course, in fact. Right?
The thing that I wrote obviously was my calculations to find that.
Okay, fair enough. Anyway, just make sure you read the questions and don't be afraid of the words. Like, we all know what a quadratic equation is, right? That's not a quadratic equation. You're like, why is this not a quadratic equation? Yes, Akuti. Exactly. There's no equal sign. It's not an equation. This is just an expression. What? All right. So that's not an equation, it's just an expression. I couldn't ask you to solve this because what are you going to solve? Right? But if I say to you, if I make it an equation, now can you solve it?
Yeah.
Answer my question. No. Separate now. Answer my question. Would you like a question? I haven't asked you a question, right? So there's no question yet. All it is an equation. I can ask you all kinds of things about this parabola, but I haven't yet. Okay, now I'm going to ask you a question, but I won't ask it. I'll just show you. Is this a question that you could answer now?
Yeah.
Now you can solve it. You understand what I'm saying? Okay, so this, not an equation. It's not a question either. It's just a mathematical expression. I have to give you an instruction. If I give you this, there's still no instructions. It's just an equation. I can graph it, but I haven't asked you anything. When I do this, well, now I've asked you a question, kind of. I basically said, when y is 7, what is x? You have something you could solve for. Similarly, if I say to you, if I give you this equation and then I write, do you now have a question? Yeah. This time I'm asking you to find y when x is negative 2. Good? All right, so give me a second. I gotta go do something for this guy. I'll fix you up in a second, okay? David, I already gave it to you. Are you guys done yet? Boys? Okay, so, yeah, give me a second. I gotta go do something in the workspace. Excuse me. Oh, this is making me upset. Not working. Alright, got that done. Now we can go back live. Alright, so now we're getting to the business. So back to our questions. You're going to have quadratic equations, and you're going to have to solve something with the quadratic equation. Well, I can either ask you to solve for x, or I can ask you to solve for y. Everybody okay with that? It's less probable that I'm going to ask you to use an equation in standard form. It's more likely that you'd be dealing with factored or vertex form. And yeah, that's what's up. So if we're starting with an equation in factored form, we're usually going to make the equation equal to 0. But if it's not in factored form, it's in standard form, that's okay. But we're usually going to convert it to factored form eventually. So this is just like finding the zeros of a parabola. Is everybody good with that? And we know that for a quadratic system, you're going to have at most 2 solutions, and at least, are there ever no solutions to a quadratic system? Yeah. So it's going to be between 0 and 2 solutions. When it's in vertex form, and you're looking for the x-intercepts, you're going to want to use reverse ops. And if it's in standard form, well, you're going to be isolating everything to one side. Again, you're going to need to write it in factored or vertex form. So the easiest way for us to do this is to actually practice. Try one out. So look at the example. I give you a quadratic equation. It's a parabola. And we know very little about the parabola, but we do know 2 things about it. So, Stella, what do we know about that parabola right there? And then ice cream, what do we know about this parabola other than it opens up? What's that? Yes? It is. We good? That's fantastic. Now, have I asked you a question? Yes, the question is good. So at what point on the graph or on that parabola does y equal 6? So if you're looking at the graph, you go up to 6, and then you look at where the parabola is. Maybe it's here and there. There's probably going to be two solutions. So how are you going to set that equation up? Because most of the time we want to solve algebraically. Very seldom do we want to solve graphically. Because graphic is loosey-goosey, and algebraic is precise. So, anybody want to suggest? Matthew? You're making it too complicated. Carbonara. That's it. So in the equation, you're going to sub in 6 for y. Everybody down with that? So what's it going to look like? There it is. Now the question is, how do we solve? David? What would be another option? If you didn't subtract 1 from both sides, what's another option that you can? I understand why you're saying that, but that's not what you want to do. Yes?
Don't you have to basically do
Probably.
so
Which is?
You take the constant, right? And you take it out of the brackets and you put them back in.
Oh, you mean complete the square?
Oh,
No, that's not what we're going to do. But that's a good guess. And this is why you've got to understand the basic language or terminology. What are we trying to do? Are we trying to find a vertex? Is that what I asked you here? No. Completing the square changes your equation from standard form to vertex form so that you know what the vertex is, which gives you your max or your min value. We're not looking for a max or min value. We're looking for the x value that goes with 6 on that parabola. So, what was the trick for solving an equation? If it was a linear equation, you could do it in grade 9 or 8 or 7 or 6, probably in kindergarten you were solving this stuff. 3 equals 2x plus 1. Do you remember doing this in grade 1? Probably. How would you solve it? Straight up BS. You understand? Now, this equation here is slightly different, right? And it's a quadratic equation, which you could also solve with straight up BS. But not all quadratic equations you can solve with BS. So what if I do this? That little change will now prevent you from solving it using BS. Do you understand why? Yeah, so try and solve it now using BS. You can't. So what was the trick that we used to solve it? There are two things that we do. Yes, before you look for the zeros, yeah, you're going to factor. That's going to be part of finding the zeros, but no. We change it to an expression which is equal to 0, and then we factor. So how can you make one side 0? What are you going to do to both sides, yeah? Take away 3. So now you have 2x squared plus x minus 3. And now you have something equal to 0. If you can rewrite this as a multiplication, we know that the only way a multiplication is ever equal to 0 is if one of the you might say one of the brackets. You can have as many brackets as you want, but notice what's between all those brackets. Multiplication. So if you have a multiplication that's equal to 0, that means one of these has to be 0. You understand? And that's how you end up solving for them. And this is true whether you have a second degree, third degree, fourth degree, fifth degree. And that's what you're going to do in grade 12 math, is you're going to look at stuff that has more than just 2 brackets or 2 factors. But for us, this is what we're going to do. We're going to have quadratics, that have two factors, and then we're going to use each factor. We're going to say this one's equal to 0 and solve it, because that's now going to be a linear factor, and the other one's going to be equal to 0. So 2x plus 1 and x plus, I don't even know if that one factors. Probably not. No, it doesn't factor. So anyway, you understand what I'm saying? So then we're going to say 2x plus 1 equals 0. And we're going to say x plus whatever is equal to 0. I just made that up. So do you understand what we're trying to do? We're going to solve this by making one side 0 and then doing what? So there it is. I made one side 0. Now we're going to rewrite it as a multiplicationization, right? Well, how do we write something as a multiplication? We factor it. That's what factoring is. It's rewriting it as a multiplication or going backwards. So hopefully you all factored it like this, and then you realize, hey, now I can set x minus 5 equal to 0 and solve it, and x plus 1 equals 0 and solve it. And do you understand what I mean when I say you end up with two linear equations? What are the two linear equations that I'm referring to, children? I know the answer is x equals negative 1 or 5. How did I get those answers? Yeah? Exactly. So if I rewrite this as an equation, x minus 5 equals 0, that's an example of a linear equation that you can solve using BS. Yes? What's the other linear equation that I can now create? Julia? Exactly. And that's a linear equation as well that you can solve by BS. So linear equations can always be solved by doing the same thing to both sides. Quadratic equations, not so much. You usually have to rewrite them with one side being 0 and the other side being whatever, and then you have to factor that the side that's whatever, not the 0. Good? That's the whole point of today's lesson. So let's do another example together. By the way, if you can't factor it, what do? You use the quadratic formula. Okay? And what the quadratic formula does is it tells you what the zeros are. So I'm just going to demonstrate something for you using a video game. All right. So what was that equation? It was look at this equation, x squared minus, or this expression, x squared minus 4x plus 1. About to blow your mind here. X squared minus 4x plus 1. You see that parabola? Okay, that's the original parabola that I started with. Now what we're doing when we're solving this, we're trying to find the point of intersection between this parabola here and another function or another relation that has a y value of 6 all the time. So if y equals 6, what kind of line do we have? Correct. Hold on. They want me to say y equals, okay. So here's what this question is in fact asking. It's asking, when does the horizontal line y equals 6 intersect with the parabola y equals x squared minus 4x plus 1? You're looking for the points of intersection between a line and a parabola. Do you guys understand that? Well, instead of doing that, instead of solving that, what we do is we create a new parabola. What's the new parabola? The new parabola is this one right here. X squared minus 4x minus 5. So if I graph that, x squared minus 4x minus 5, that's the purple parabola. Well, what do I want the purple parabola for? I'm looking for x values. The x values I'm looking for are the points of intersection between the blue line and the blue parabola and the green one. Y'all understand what I'm saying? I'm looking for these 2 points right here. That one and that one. Rather than find those points, I created a new parabola, the purple one, and I'm just going to find its zeros. Well, why is that useful? Because the x values of these zeros are going to be the same x values of the points of intersection between the blue parabola and the green line. That's the whole point of doing this. Y'all get that? Slick, right? And so, if we were to take a more complicated example, take for example, next year you're going to look at third degree, fourth degree polynomials. That means y equals x cubed minus 3x squared plus x. Or you might have to the power 7, x to the power 7, and it just tells you there's more zigs and zags. Well, if I factor something that's cubic, how many factors should I get? 3. So I'm just going to graph it in factored form. Okay? Oops. X minus 3, x minus 1, and x plus 2. All right, so maybe what I do is I can expand and simplify that, and you know I'm going to have a cubic in standard form. And then I want to know when is the the y value going to be 2. So that would mean I want to know when a horizontal line at 2 crosses that particular cubic function. So here we go, y equals 2. So I'm looking for these three x values. You understand what I'm saying? Well, I'm not going to solve that. What I'm going to do is I'm going to make the left side of this equal 2. Then I'm going to make that side equal to 0 by subtracting 2 from both sides, and then I have to refactor the whole thing. And I'm going to create a new cubic function whose zeros are going to have the same x values as this. Yes? Yes, you can. All right, so back to this. Let's do another example and see what we can figure out. So rather than having the equation in standard form, this time the equation's in vertex form. We want to know, this equation describes the height of a ball. What's the height of the ball when time is 0? What? You sure? I understand why you're saying that. We don't know, right? You'd have to solve for it. What's the maximum height of the ball? Yes, how do you know? It's the y coordinate of the vertex. And the vertex is always going to be your max or your min, right? Now, how would you find the y-intercept? If it were in standard form, you'd just say whatever the constant is. So you could change it to standard form. Or what's the other option, which is probably easier? Exactly, sub-0 in for x or for t. So then you're going to have 0 minus 4, negative 4, square it, 16. 16 times 5, 50, 80. So you've got negative 80 plus 180. What's the y-intercept? It's 100. Yeah, are we good? You guys get it? Anyway, that's not what we're trying to do. We're trying to find the time when the ball is at a height of 130. So tell me what to do with my equation now. What do you think, Muffin? So I want to know when it's at a height of 130. So we're going to use the number 130, right?
Yeah.
We're subbing in for height? Well, you can sub it in for either t or for h of t. Which one do you think is correct? Okay, there's no mention of of inverse here, right? For h, exactly. So what we'll do is we'll rewrite the equation like this. Cool? So on the left side, we have most of the equation of a parabola in vertex form. On the left side, we have the equation for a horizontal line. We're looking for the intersection between the horizontal line that's at 130 and then the parabola that's got a vertex at -4 and 180. Well, rather than find the points of intersection, we're just going to create a new equation, right? Or a new parabola. So what are we going to do to our equation right now? We need to make one side. Which side is it easier to change to 0? The left side. How are we going to do that? That's BS. Correct. So let's subtract 130 from both sides. Boom. Oh, wait a second. I didn't do that. Now we could do that. But when it's in vertex form, there's an easier way. Because vertex form, remember what we can use at this point? We can actually use BS for the rest of the way. But what we're going to do is, just for practice, talking about practice, we'll do it. We're going to go with 0 equals plus how much? 50. So now what we would need to do is take a guess. What are we going to do with the right side? We're going to expand it and simplify it, and then we're going to need to factor it. Okay, that's one way. So -5t squared. This is not the ideal way. I'm just showing you though. -5t squared. We're going to have -8 times -5, 40t, and then we got 16 times 5, which is 80. Minus 80 plus 50 is minus 30. Okay, so y'all understand that now we have a new parabola. And what do we have to do with that new parabola? Write it in factored form, and then make two linear equations equal to 0 and solve them. Cool? Or the more efficient method is in black on the left. So can anyone guess what the more efficient method is? On the left in black, you got 130 minus 180. What's that? It's -50. Okay, so what would you do next with -50 equals all that stuff? Yeah? Divide by -5, that gives you 10. Then what? So you're going to get rid of the square? How? Oh, and what do we remember about square root? We remember x squared equals 9. Boom. So if we take the square root of both sides, plus or minus 10, root 10. Yeah? And then what's the last step? What's the last step? Add 4 to both sides. So there it is. So the ball will be at a height of 130 at 4 seconds. Well, actually just a little bit more than 4 seconds and just a little bit less than 4 seconds. How much more and how much less? The square root of 10. So the square root of 10 is let's just say it's 3.1. Okay? So you got 4 seconds plus 3.1. So that's 7.1 seconds. And also at 4 minus 3.1, so 0.9 seconds. Those are the two solutions. Cool? Could we not have continued in purple, though, on the right? Yes, we would. So what would be the next step? Well, my next step would be, I'm trying to factor it. You always start factoring by? Exactly. Do you see a common factor? I hope it's -5. Y'all down with that? Okay, this is going to confuse you a little bit. You know how I tell you whenever you factor out a GCF, don't lose it, right? Well, there's a difference between when I ask you to factor something and then I say don't lose your GCF and this. What's the difference? I'm not asking you to factor this. I'm asking you to solve, right? What's the difference? How am I getting rid of it? Exactly. If I divide both sides by -5, I haven't broken any rules. I'm just BSing, and I haven't lost track of anything. But if I didn't have the 0 equals, then I can't drop that -5. I can't let it disappear. It's got to stay there because I'm just factoring an expression. But now I'm solving. So my next step would be this, t squared minus 8t plus 6. And you can try and factor this, but it's not going to work. How do I know it's not going to work? Because I already know the answer. I know the answer is going to be like 0.9 seconds and 7.1 seconds. And factoring with those solutions is pretty difficult. So what would you use? QF. Quadratic formula. And again, I told you guys, if ever you need the quadratic formula, you don't remember it, just ask me. So the quadratic formula is this. X equals -b squared minus 4ac over 2a. Throw in a little rad sign to keep things rad. And there it is. Now, what do the letters A, B, and C mean? Yeah? Tools for digging? What about them? You're right. Give me one more word. Starts with C. There it is. The letters A, B, and C are the coefficients of the second degree term, first degree term, and constant or 0 degree term. So A is this right here. B is this right here. And C is this right there. You guys understand? You know how to use it? And so you can solve it. You're going to get exactly the same answer that we got with the other method. So when you have an equation in vertex form, it's better just not to expand it and solve it. Just use reverse operation. If it's in standard form or in factored form, you're going to want to isolate everything to one side, expand it and simplify it, and then refactor it. Cool? What's up? Do you see the plus or minus? That's what gives you the two answers. It's basically the same plus or minus that you got when you took the square root of both sides. Cool? So that's how you get two answers. Now, this number here, what do we call the number that's under the radical sign? Yeah, it is the radicand. Well, for the quadratic formula, the radicand is b squared minus 4ac. Anyone remember something special about b squared minus 4ac from last year? So special, they gave it its own name. Yeah. It does? Anybody remember what it's called? Yes? It is the discriminant. And when the discriminant, can you guess what number the discriminant has to equal in order for you to have only one solution? What? No. Somebody else said it. Yeah. Why do you only get one solution when the discriminant is 0? Well, whatever's outside the radical sign is a number. Take a number, and what can you add or subtract to it, and it doesn't change the number? 0. So if your discriminant is 0, you're going to get one solution. If the discriminant is a certain number, or a certain type of number, you get no solutions. Anybody know? Yes? There it is. If your discriminant is a negative number, the alarms are going to sound. It's a blatant disregard for proper procedure. There's an intruder in Sector 5. You're trying to take the square root of a negative number. It's kind of like trying to divide by 0. Your calculator is going to melt. You understand what I'm saying? So whenever that happens, you have no solution. Well, how could you possibly have no solution? Remember what we're doing. We're finding the zeros of a parabola, the x-intercepts of a parabola. Is it possible for a parabola not to cross the x-axis? And that's what you have. You have a parabola that doesn't cross the x-axis, so you have no zeros or no solution. And then when do you have two solutions? When your radicand or your discriminant is a positive number. That's it. Good? We're almost done. I haven't heard Chloe put her hand up yet, so that's a good sign. She's not sleeping. Okay. Chloe, put your hand up. Did you hear it? Yeah, respect, Chloe. I appreciate you. By the way, it was Java Fruit that was calling you out. The same kid that's never on time for class. You were in class before he was today by Google Meet. This guy, no, she's home now. Anyway, all right. Chloe, do you have any questions? Right on. Right on. So, do you guys understand more or less what today's lesson was about? You're going to have a quadratic equation, and you're going to have to solve for something. That usually means make one side 0. If it's in vertex form, you don't have to bother making that side 0. You can just go right to BS, which is nice. Okay, so if I were to look at a textbook question from the homework, we can just make sure y'all are on the right track. Then we're going to get rad with it. What page was that stuff on? $177. What page am I on? 159. 170. So close. Okay. All right. Would you all agree that question number 1 is basic? Check it. Find the roots of each equation by factoring. Easy? Don't get messed up. Always start with GCF. Now, none of the questions in number 1 have any GCFs. But look at C. What are you thinking right away for C? Another 3-letter acronym. There it is. Difference of squares. What are you thinking for A and B? Probably product and sum, but I would suggest just go trial and error. Think about the FOIL, right? Work with the F and the O, and then make the OI fit. And then for D, that one's a more difficult one. If you're doing product and sum, this is a decomposition one. Okay, it's not a shortcut one. So you're gonna have to take it and split it up into 4 terms. But what would be easier would just to be using trial and error. And why is it kind of easy? Well, your first degree coefficient is 2. So that tells you that when you factor it, you're going to have in one bracket's 2x and the other bracket's x. And then you need factors of 4 for the next 2 numbers. Cool? Use the quadratic formula to determine each of the roots. So this time you're going to solve using the quadratic formula. Graphing calculator. If you're trying to do the graphing calculator stuff, hit the video game. Which strategy are you going to use to solve these guys right here? All right, look at 4a. How are you going to solve that? If you were trying to visualize this, Jaheim, if you were trying to visualize 4a the way that we did with Desmos, it's like you have 2 parabolas. They both open up. So you got 2 parabolas. They're asking you for when they cross. Well, they might cross once. They could cross twice. They're asking you for the points of intersection of those 2 parabolas. let's make things easier. Let's just make one side 0, and on the other side you're going to get a new equation for a new parabola, and you're going to find the x-intercepts of that new parabola. You're going to get the same solutions, the same x values. You guys get it? Are you going to need to factor for that one? Yes. Which of these, A, B, C, D, E, F, will you not need to factor? A bit of a trick question. Which one would you suspect you probably won't need to factor? Julia? Yeah. So F, you're going to have to factor it. I understand why you said D. Can anybody explain why she chose D? Because it's in vertex form, right? The one on the left is in vertex form. The only problem is the one on the right is not a constant. So you will have to make one side 0. You'll have to expand and simplify the whole thing and then factor it. So in fact, all of these, you're going to have to expand, simplify them, isolate them, one side 0, then factor. For number 5, same thing. They're looking for the x-intercept, so it's nothing too difficult. So you're going to need to use the quadratic formula for number 8 if you're doing number 8. Number 6, determine the break-even point. Remember we talked about bitness? Break-even point is a very important event or a very important value. You guys know what a break-even point is? Why do people generally go into business or start a business? To make money. If your revenue is $1 million, did you make money? Not necessarily. Depends on. If your expenses were 1.5 million, did you make money? No, lots of revenue, $1 million bills, y'all, making it rain with your $1 million. Oh, you don't have $1 million. You have less than 0. You have negative $500,000. You're in debt. You are under the break-even point. Guess what the break-even point is? What's 0? No, the break-even point is not 0. Profit is 0. The break-even point is when your revenue is equal to your expenses. And profit is revenue minus expenses. So when revenue minus expenses equals 0, that's your break-even point. You understand? So they're asking you for break-even point, which means find the zeros of the profit function. All right, enough of that. You guys will do your homework, but I want to talk about radicals. We only have a few minutes left. Did anyone try any of the radical worksheet? And how'd you do? I'm guessing some of them you found difficult. Okay. Thank you. Here's what we didn't finish yesterday when we were doing radicals. We did not finish practicing converting from mixed radicals or entire radicals to mixed radicals. So here's an example. Let me add a little screen cover. Remind me to give you your quizzes back too. And to do attendance. All right, children, I want you to rewrite these because right now you're getting teed up hard. Yeah, you're getting teed up, but this is your answer. So this is an example that goes with yesterday's lesson, and we're trying to simplify it, which means we're trying to add and subtract radicals. But we know that you cannot add any two radicals together. They have to be, yeah, it's like terms. We call them like radicals. So first of all, change them. It's like reducing a fraction. Change them. Do it. David, why did you want your paper back? You did it fine. Yeah, no, you're good. Who's the other person? Oh, Diego. Diego. Only the people that show up on time, though. Diego. I'm only going to give you 1 mark if you get it right, though. What's your name again? Nice to meet you, James. You new to the school? Oh, wait, I'm not supposed to smile. You guys done? Woulda, shoulda, coulda. Next time, just do it. Read the question and do it. Jaheim. You kind of did it. What did I do? Okay, so, yeah, I'll give you the.
Did it?
Well, you kind of did it, but then you did this, which you weren't supposed to.
So I just did it out.
Well, yeah, because this is what you're not completing the square. I asked you to pick the number, and then you made a new quadratic, and then if you were to factor it, it would just be this. This is your answer right there. Factor. Because you're not trying to add 0, right? So, all right. Are you guys done? What's up? All right. So your next line should be all the radicands factored. But what kind of factors are you looking for? L? Square numbers, right? Yeah, you're hoping that one of your factors is a square number, and that's going to allow you to take the square root of that factor, bring it out and combine it with the existing coefficient. And so, what 2 factors would you use for 75? What do you got, Muffin? What times what gives you 75? All right. Who's got this? Yeah. Okay. Is 25 or 3 a square number? We're on the right track. How about 32? Who wants to tell me the 2 factors for 32? Why not 4 and 8? No, 16 and 2 is better actually, but why not 4 and 8? 4 is a square number, so that would work. But the thing is, 8 can be factored to 4 and 2. So you have another square number, right? So 16 would be better. What about 50? What are we talking, Radish? 50? What are you going to factor 50 into? Didn't do it? Yo! Ice cream. 25 and 2? You good with 25 and 2? And then 27? No. Yes, Rhea. It is 3 and 9. So this is what your next line should look like. Hopefully you guys can read my writing. 25 times 3, 2 times 16, 25 times 2, 9 times 3. These guys right here You're going to take the square root of all those square numbers. And what's the next line going to look like? Tortilla. What's this going to look like when you simplify it? Oh, you weren't here. That's right. Okay, Diego. Do it. First one. Simplify it. 5 times what? Oh, come on. Somebody help me out. You know? Yeah, go ahead. Rice, go.
Oh, it would simplify 5 times the 15 square root of
15 root 3. Everybody get that for the first term? Okay, second term, tyranny. What's it going to be? Yes? Just tell me the answer. No. -8 was good? Thank you. And Steak, you got the next one? Perfect. And last one. Do you have it? -12 root 3. So this is what it should look like. Do you see any like radicals that you can combine? Remember, don't combine the radicands. They're fruit. They're telling you what fruit you have. So you got 15 mangoes, and then you have -8 kumquats, and then you have 30, what are those? Kumquats again, yeah. And then you got -12 mangoes again. So only combine the mangoes and the mangoes, and the kumquats and the kumquats. This should be your final answer. What's a kumquat? It's like a tiny oval orange. They're like this big, and they taste like oranges, but you don't peel them. Yeah, you don't peel them because the peel's really, really thin, and they're delicious, but they're expensive. I don't know. How big are they? Okay, I don't think I have. Nice. What? Apricots? No, I don't think so. What's up? Oh, you want your quizzes back? Okay. While you're waiting for your quizzes, why don't you try this question right here? Hey, I want you to fill in the blanks. So you've got root 27, change it to a mixed radical. That should be easy. You already did it. And then what if you had a mixed radical and you wanted to change it to an entire radical? Try that. And also quit your whining. One other thing. Why don't y'all write your last names on your stuff so that I know who you are? Because my list is by last name. So then I'm trying to find you on my list. I'm all over the place. Be nicer to me. All right. So that's it for today, Chloe. And I'll do this tomorrow again if you're not in class, okay? All right. Take care. Hope you feel better. Bye.